Well, good afternoon, everybody. Um, Thank you for being here. My name is John Dernbach. I teach here, and I direct the Environmental Law and Sustainability Center at the school. Today's presentation, How Regulators Should Address the Potential for Stranded Shale Gas Assets, is an important talk about an important topic. In 2017, Pennsylvania was the second highest shale gas producing state in the country. And Pennsylvania is in the middle, as I think probably everybody in this room knows, of building a considerable pipeline infrastructure to move that gas to market. Yet there's growing demand, public demand, for action on climate change, and the price of wind and solar is falling fast enough to put the competitive position of gas over the long term in some doubt, even if there is no further government action to address climate change. So the possibility exists that much of the state's natural gas reserves, wells, and infrastructure may no longer be used at some point in the future. What should regulators consider or do now to address that question? This is precisely the issue that today's speaker, Professor Heather Payne, will address. She is an associate professor at Seton Hall University Law School and an emerging leader in the areas of energy law, environmental law, and evolving regulatory policy. A former chemical engineer and corporate executive, she brings a deep understanding of both the technical and economic implications of policies to address new realities in a carbon-constrained and a water-constrained world. Before joining Seton Hall in 2018, Professor Payne was fellow and assistant director of the Center for Climate, Energy, Environment, and Economics at the University of North Carolina School of Law. Prior to academia, she clerked on the North Carolina Court of Appeals and worked with Sears Holding Company and Honeywell International. She holds a bachelor's degree in chemical engineering from the Georgia Institute of Technology and a law degree from the University of North Carolina School of Law, where she graduated with high honors and served as a member of the Law Review. I must also say that she is a wonderful colleague. Before turning the podium over to her, I have to say this because I'm in charge of the center, a couple of announcements about upcoming environmental events. Keith Welks, who is Deputy Treasurer for Fiscal Operations for the Pennsylvania Department of the Treasury, will be here on Tuesday, April 23rd to speak on financing Clean Energy's silent partner. He will be here in this room at 4 p.m. On Friday, April 26th, again in this room, we will be holding an all-day conference entitled Legal Pathways to Deep Decarbonization in Pennsylvania. It will be available for 7 CLE credits, including an ethics credit. This conference will ask what legal choices Pennsylvania should consider to reduce its greenhouse gas emissions by at least 80% by 2050. The conference builds on a book that Michael Girard at Columbia Law School and I have edited that has a similar title, Legal Pathways to Deep Decarbonization in the United States, which identifies more than 1,000 legal tools that federal, state, and local governments, as well as the private sector, can employ to reduce greenhouse gas emissions. And that book, by the way, is just published yesterday. So I'm happy about that, and a lot of us are. So we will be busy that week. But in the meantime, and most importantly, please welcome Professor Heather Payne.
Thank you, John. I am very excited to be here to talk with you today. But first, I think the question that we have to start with is, why now? Why are we starting to talk about the potential for natural gas assets, which for so long were actually talked about as essentially a mandatory part of our future, a bridge toward clean energy and away from coal? Why are we starting to have a conversation at this point around the fact that we may have shale assets, natural gas infrastructure that ends up being stranded? And really the impetus is the scientific consensus that is building around the fact that our assumptions about our future may not have been accurate. And for a long time, we had settled as a global community on a goal of 2 degrees Celsius. That was essentially where we needed to be to make it so that we didn't have catastrophic climate change. And in October of 2018, the IPCC put out a special report around climate change, and it was a review of 6,000 scientific studies that looked at the potential difference between keeping climate change at 1.5 degrees above pre-industrial levels and 2 degrees above pre-industrial levels. And again, for a long time, the scientific community had said 2 degrees was fine, and there was a push by, in some cases, at least initially, political forces to say we needed to change. Well, this report came out and very clearly detailed that there is a stark difference between what it is going to mean for our planet to be at 1.5 degrees or 2 degrees above pre-industrial levels. And if we keep 1.5 instead of 2, 50% fewer people around the world will be exposed to water stress. We will have hundreds of millions of fewer people subjected to climate-related poverty. We will reduce food scarcity problems. We'll have a 50% less decline in marine fisheries, which are already stressed due to both overharvesting and ocean acidification. We will have 10 million fewer people who are affected by sea level rise by 2100. And we have better odds that at least some percentage of the coral reefs will survive and subsequently recover. Along with this study came out the fact that if we are to keep to 1.5 degrees above pre-industrial levels, humanity has about a dozen years, the scientists think, to hold off the accelerated risks of extreme heat waves, wildfires, flooding, drought, sea level rise, and the extensive poverty that would result. So with this, we start seeing a scientific consensus around the fact that keeping to that 1.5 degrees C level is doable from a physical perspective, but it is going to be incredibly difficult and require unprecedented changes throughout our economy. And if we're talking about consensus, I want to be clear that I'm not discussing policy consensus. There is no policy consensus around how we should actually address the challenges that the scientists have essentially put in front of us. That debate is ongoing. But there is quite a bit that says that something needs to happen, and it may end up happening faster than many of us have realized. When we start thinking about what that means for business, and therefore regulators, we know that that actually does translate into business decisions that are likely to be made in the future. So Wood Mackenzie looked at a plan for accelerated decarbonization, and they found that it would include a number of business decisions. We would have oil peaking in 2031. Wind and solar would represent 40% of total power globally by 2040, up from about 7% today. Internal combustion engine cars and trucks would peak in the late 2020s, with 100% of new vehicles being electric in the US and Europe by 2040. Electric cars would replace 11 million barrels per day of oil consumption. And we would have 64 million autonomous cars on the road by 2040. However, even if we think about what dramatic changes that may bring about, those actions will not meet the goal to keep warming to no more than 2 degrees Celsius, and much more radical action would actually need to occur to achieve an outcome of 1.5 degrees above pre-industrial levels. That's a little bit in the future. But what we're seeing is that this scientific consensus is also impacting businesses today. Pacific Gas and Electric, based in San Francisco, is looking at fairly lengthy bankruptcy proceeding. Now, some things about PG&E's bankruptcy are definitely California specific. Nowhere else has inverse condemnation for the kinds of wildfires and therefore the liability that PG&E is dealing with. One of the potential options is to actually split up the gas and electric parts of the business. When looking at that, Bloomberg actually said that PG&E may sell California assets nobody will want in 20 years. And so there is a real case to be made that at least in that environment and the fact that California has a very, very strong regulatory response to climate change, you could have a system that has 4.3 million customers and generates more than $4 billion in annual revenue, essentially sold at not a nice increase in price, but actually at a price that would seem illogical because of the potential for those assets to not have value depending on what the state does from a regulatory perspective in a relatively short period of time. And part of that is because of the state's ambitious environmental goals. California has passed 100% clean energy by 2045, and so its stringent regulatory climate may actually mean that its natural gas infrastructure would be worth less. Now, is this only a California phenomenon? Not for regulators. And the reason is because we do have increasing calls for changes in energy and transportation in at least a majority of states across the country. These are taking different forms. Some of them call for 100% renewable mandates. Some of them are 100% clean, which would allow, of course, nuclear, carbon capture and sequestration, other technologies to continue in those states. Other states are looking at 80% goals to find a way to make it more manageable in terms of economics, but still take definitely significant action. SMUD, one of the top 10 largest municipal utilities in the country, is not running new natural gas infrastructure to housing subdivisions. Any new housing in its territory is purely electrical. So heat pumps are replacing your traditional HVAC units. Hot water heaters are all electrical. And this goes to a call that we are seeing more places to essentially start electrifying everything. Now, when people talk about that, in large part, they are focused on transportation assets, but we see places like SMUD that are taking this not only to transportation, but to housing, and saying that everything within that jurisdiction is going to move to electricity, and therefore, as the electrical grid becomes more renewable and more clean, that will filter through the housing and transportation ecosystems as well. This is, though, a significant challenge. And the reason is because we have about $160 billion invested in U.S. gas utility distribution plant service at this point in time. This is within regulated utilities. This does not include all of the infrastructure spend that has occurred in pipelines or other production infrastructure. Once we add that in, we're talking about an even higher number. This number comes from S&P Global Market Intelligence, and the other interesting thing is that it's been increasing at about 5% a year. So the longer that we wait to take any sort of action on these issues, the more capital infrastructure will be invested. So the question then becomes, as regulators start thinking about the system as a whole, what should they be taking into account? The first, I think, has to be safety and reliability. San Bruno, the deaths in California, deaths in Colorado, deaths in Texas, deaths in Massachusetts, have put into sharp relief for regulators and the general public how much safety needs to be at the forefront of operating our system. The challenge for that then is, if we actually do find the need to start shutting off parts of the system, how do we do that in a way that is economical? If the policy choice that is made is that we need to stop using these fuels, how do we think about that? Everything that we think about with utility systems is about expansion, right? When we're talking about putting in water and sewer infrastructure to new suburban developments, it's all about, can the existing infrastructure actually manage the expansion and the new flows that are going to come with that? Rarely, if ever, do we think about taking a system and actually starting to wind it down. And that is going to be one of the critical questions for regulators if, as a policy decision, we say that's what has to happen. There are several options out there. One is that we figure out sections at a time. Look at where there is the oldest infrastructure and figure out how we move those systems, those people off of those systems first, so that we're not replacing that infrastructure with the knowledge that it is then going to not be used for an extended period of time. Of course, the other option is that we essentially keep the whole system at the level of safety that it needs to be until we essentially decide to turn it all off at once. There are challenges with both of those proposals. And we're not going to get to an answer today of how we're going to make this happen. But this is not the way we think of energy infrastructure. And if we are looking at a potentially carbon-constrained world, it is something that we are going to actually have to start thinking about. Societal and economic trade-offs are obviously going to be a huge consideration as policymakers and regulators think about these issues. And that can be everything from the benefits that are going to accrue as we make this transition, but of course, it also deals with the drawbacks. And those drawbacks, at least in energy, are already somewhat well known. We know what the impact is when we shut down plants. There are a lot of places that have lost their coal plants. They would be more than happy to tell you about their experience. Nuclear plants that have shut down have also faced similar challenges for the towns where they are located. So the town where Indian Point is located, which is set to close in 2022, is trying to figure out how a third to one half of their tax base is going to be made up once that plant shuts. These are not new issues, but they are not ones that historically regulators have necessarily looked at as they were planning infrastructure. And we should actually be thinking about them as we think about winding down the system. And then compensation for stranded assets. Stranded assets, using the Webster's Dictionary, is a term that describes something that has become obsolete or non-performing well ahead of its useful life and must be recorded on a company's balance sheet as a loss of profit. I like to think of it as existing energy infrastructure that retains some useful life, but that can no longer generate the initially expected revenue due to regulatory shifts, market forces, or innovation. And the potential for stranded assets is very large. We have the $160 billion in distribution assets that may end up decreasing in usefulness. By an estimate in Utility Dive, the stranded asset figure on gas plants and the infrastructure to serve them could lead to an additional $100 billion. By other estimates, it could be as much as $1 trillion in stranded assets by 2030. So we are talking about very significant amounts of money. And of course, how that is going to be spread between ratepayers and investors is a very open question. So how then have we thought about these ideas in the past? Well, in energy, obviously, one of the main ones was partially constructed nuclear plants in the 1970s and 1980s. We had over 120 partially constructed plants that were canceled. And what regulators did, confronted with those costs in their regulated utilities, actually fell along three main pathways. The first is that they allowed full recovery for everything that had been spent up until that point in time. So even though these plants were never used and useful, they never came into service, and the ratepayers never received any benefit from them, that full cost was passed on to the captive rate base. In some cases, regulators allowed not full recovery, but partial recovery. And this was because there was a thought that investors should carry at least some of the risk for those projects. In a small number of situations, you had regulators allow no recovery, under the theory that the plants were never used and useful, that capital never benefited the ratepayers, and therefore the captive rate base should not actually be the one to have those charges. These all, of course, were in situations where there was a regulated utility, and like many of the investments in gas infrastructure, at least up until 2015, if not even later, those would have been considered prudent decisions for the utility to make. So when these nuclear plants were started, it was determined that they were the best path forward. They were prudent to start construction. It was only later in the process that it was determined that they should be canceled, and so the plants were never used and useful. I don't think that anybody would argue that especially much of the infrastructure, when it was put in place, was not a prudent decision. But the question, I think, for regulators will start to be, at what point does that prudency stop? And SMUD has said it's already there. It is already not a prudent decision for us to put in new gas infrastructure. Deregulation and restructuring of the 1990s. Another place where we had significant stranded assets as we were making transition to a wholesale competition market. And FERC, in this case, did allow 100% of stranded costs associated with the transition. Some states, however, did not, as they were transitioning to a retail format. I think learning from this situation that regulators can take away is how much the estimates varied about the costs of the stranded assets. So the initial estimates were somewhere between $100 billion and $500 billion for us to move to a competitive market. And the majority of the estimates were somewhere between $100 and $200 billion. In hindsight, the stranded assets ended up being closer to about $10 billion rather than the 100 to 200 that most of the estimates actually fell within. And that, I think, is somewhat a lesson because of when it was made. These decisions around whether an asset would be considered a stranded asset at that point in time was made long, long after the initial capital outlays. All of those investments had been used and useful. But interestingly, when in both of these cases, regulators were looking at how they should value the stranded assets and what they should do, they didn't necessarily take those other considerations into account that I mentioned earlier. And so while we have examples, they weren't necessarily accurate in terms of estimates, and they certainly did not provide a clear path for what a majority of states even decided to do. What else could we look to in terms of analyzing what might happen if we're looking at shutting down the system as a whole? We do have statutory mechanisms in place in some states to stop providing other services. The ones that I like to think about here are roads. So most municipalities and states essentially have a duty to provide some form of road access. And there actually are statutory provisions that deal with when a municipality or a state will stop providing road access. Is it problematic? Yes. Can it potentially lead to takings claims? Yes. But might it actually provide a way for legislatures to start thinking about statutory schemes that could deal with the infrastructure that exists? Possibly. So what really are our paths forward? Well, regulated utilities, unsurprisingly, are already thinking about this. Utilities are running scenarios about what a world with no natural gas would look like, how that would impact their assets, how that would impact their revenues. If they're already thinking about it, then I would argue regulators should start thinking about it now. And how then could we go about looking at it? Well, allowing recovery, as we have done with nuclear plants and the transition to a deregulated system, certainly is one potential path forward. However, not all states went that way, and so we may see a disallowance of stranded assets by states in specific situations. But this is, again, very tricky when we start thinking about the fact that we need to maintain the system in a safe way. And how we're going to do that, knowing that that is going to require at least some amount of infrastructure investment in the meantime. So another thing that regulators could think about is essentially putting in place the specifics of stranded asset recovery before projects are approved to begin with. This would essentially be putting an expiration date on a particular type of energy infrastructure. And this is, I think, a very important concept because our energy infrastructure is not good at being temporary. And because it is not good at being temporary, we don't tend to deal with transitions well. So it's going to take at least some consideration for regulators to think about how they start thinking about that transition before it actually occurs. If we're allowing recovery, there are a number of ways that we can do that. Securitization is actually becoming one way that local plants are dealing with coal-stranded assets. And so that certainly is one. If we're talking about looking at the specifics of stranded asset recovery before projects are approved to begin with, one way to do that would actually look to see if a plant, if it is out to 2030 or 2035, if that project, if it was fully depreciated by that point in time, would still make sense. And if the answer is yes, put it on that kind of a depreciation schedule if it's within a regulated entity. If the answer is no, that having it cannot actually make sense economically to be fully used and useful within that time frame, look at other options that might be. And so this is not, as I said, something that we're going to solve today. But the science is increasingly clear. As John mentioned, that is increasingly making it so there are more discussions around what we need to do from a political perspective, which will not only impact businesses, but which will impact regulators. And so with that, I'm hoping that we can go ahead and start thinking about how we view our infrastructure potentially differently, and therefore how we can actually make it so that that transition, whenever it occurs, is the best possible for both our communities and for investors and ratepayers. Thank you very much.
Tom, it looks like you've got a question.
Oh, okay, I'll start. My name is Thomas Howe. I guess I start with the fun little question, how you distinguish between a regulated asset and a non-regulated asset, because I think you've been talking about terms like gas distribution systems as a regulated asset, and a lot of the things that you would maybe put into the category of non-regulated might be pipeline systems, gas power, electric generating stations, and such. So where does that line end?
So when I think about it, I'm thinking about whether there is a captive rate base that stranded asset costs could be borne by, or if any stranded assets would be purely borne by the investors. So whether that business is purely market-driven or has a captive rate base. So yes, for the majority of especially transmission pipelines or power plants, merchant power plants, I would view those as unregulated assets. However, I do think that there is a very potentially challenging question for regulators, because if you have a situation where the state still takes some active participation in terms of approving power plant build, which is not so much the case in PJM, but which certainly exists still in many other parts of the country, then you may have a situation where the power plant is technically part of a regulated utility, but the pipeline infrastructure to serve it is actually part of an unregulated subsidiary or an unregulated sister company. And there, I think you're actually going to have a situation potentially where the company who developed the pipeline will claim that they actually were only doing it because the regulators had approved the additional power plant infrastructure for the regulated side of the business. And if they hadn't done that, then the pipeline infrastructure wouldn't have been built. And therefore, they, even though they're technically an unregulated part of the business, deserve cost recovery as well. So I think that very much, a situation like that very much depends on where in the country you are and what your particular restructuring looks like. But it is something that different parts of the country are going to be dealing with in different ways.
Non-regulated company and has asset, and in the decarbonization proposal, you would not be entitled to any recovery or relief.
Historically, that has been the case, right? Historically, we have said that that would be completely borne by the investors. And that certainly, I think, is something that state legislatures may need to grapple with, especially in a state like Pennsylvania. But that would come from, I would say, legislative action, probably more likely than action within the purely regulatory sphere based on precedent.
Hi, I'm Diane Dustman, and I work for the Consumer Advocate's Office in Pennsylvania. And I have a couple of questions. The first one is whether you have considered how the process of abandonment of certain service territories might, in a micro way, provide a model for disassembling or taking parts of what will be an antiquated system out of service.
Not in particularly that specific way, but I definitely think it could. I am not familiar with places where that has gone particularly well, and it seems to be, at least for the examples that I'm aware of, that's because it happens essentially by attrition and other factors as opposed to as part of a conscious decision. And so I think that limits it slightly because you don't necessarily have the same factors in play, but I think that it could be a useful example.
Yes, I agree with you about the attrition part, but over the last couple of decades, we've worked on a handful of abandonment cases. And there are some examples where a company determines that a certain part of the system has become uneconomic. And where we agree with that, we then try to assist with transitioning the customers to another form of energy supply, for example. And it has worked out in some cases where everybody winds up happy, which is a really unusual result.
That's great.
But my other question is, and this is what I'm grappling with through your comments, is that we are interveners in a high voltage transmission line case right now. And in those cases, the FERC generally pre-approves abandonment costs if the project is let go through no fault of the transmission owners. And the customers just automatically wind up paying with the caveat that we can challenge some, say if we find imprudent costs, or we can challenge the return levels on that.
Right.
But ultimately, the customers always pay, whether the line goes through and gets built or not.
And that essentially is what a lot of states did with the nuclear plants, right? So it was, in those cases, they were actually partially constructed in many cases. And so you had a significantly higher level of capital that had been outlaid. And so with the FERC abandonment, I think that's typically until the line actually gets built. I'm not sure that I've seen one for essentially the line being built and then abandoned.
Correct. I haven't seen that either.
Yeah. And I think that that's going to be a question that regulators need to deal with, or essentially the things that we build. Because I don't think that anybody's saying that we're never going to build another pipeline.
That's correct.
Exactly, right?
Because there's a huge push right now towards expanding the gas infrastructure
Exactly,
in
right?
Pennsylvania.
Well, not just in Pennsylvania, right? There is all up and down the East Coast.
Mhm.
So we're not going to have that precise situation. But I think the question is, at least for regulators, as we're looking at expanding that pipeline, what do we actually think the used and useful life of that pipeline is going to be? Is it going to be 2030? I would say we're not going to make the transition that fast, but there are a lot of people who are starting to push for it. Is it going to be 2035, 2040, 2050? Even if we're talking about 2050, a pipeline that we put in the ground today is more than likely not going to be fully depreciated by then. And so that, I think, is going to be the question that regulators really need to focus on is, what do we, when we are approving this infrastructure, what do we actually expect its used and useful life to be? Because it is unlikely that we are going to be expecting that to go based on the ductile iron. And whenever it's done, it's done. That's not going to be where the calculus ends up going forward.
Comment, no other state has inverse condemnation laws like California. And is that what you said?
At least not that I'm aware of.
Okay. Do I infer from that because PG&E, for example, is a public utility, they have the power of eminent domain, therefore there's some concomitant principle that if they burn your house down, that's considered an inverse condemnation? Or
No,
is there more
so
to it than that?
it is more than that. So the inverse condemnation law in California around utilities is that even if they are not negligent, and even if they have followed all regulatory practices, followed all safety guidance, everything, for any reason whatsoever, if their equipment is found to have been the cause of your loss, they are strictly liable for it.
Product liability thing, do they have to show that there was a defect or just
Just that it happened.
strict liability? Okay.
Just that it happened. So if they are found to be the cause of a fire, their equipment, it doesn't matter if they did everything that they were supposed to, if they did all of the tree trimming they were supposed to, if they did all of the preventative maintenance that they were supposed to, if they actually had, if they were the cause of the fire, that's it. They are 100% liable for all loss.
Were they not adequately insured for that?
So they did actually have a fairly good insurance policy, but the fact is that they were coming off of a 5-year drought. There was a lot of standing fuel. There was an exceptionally wet winter that then created even more fuel. And when you combined that with the millions of trees that had essentially almost died because of the 5-year drought, they were inadequately insured for the level of destruction. And it did not help that it happened 2 years in a row. So you had fires in 2017 and in 2018. And so it's that combination of liability that really drove them into bankruptcy.
I don't want to monopolize, but if nobody else has a question, I'll ask. Another thing I was kind of grappling with through your comments was, you know, where does I know you focused on natural gas, and I totally understand that, but what is the future of the electric grid, considering all the things that you discussed? I know it's really general, but you've probably thought about it, so.
Yeah, so I think what the general thought is that you actually will certainly continue to have a centralized grid in some way, shape, or form. Obviously, if we're moving to decarbonize by electrifying everything, you're going to have electric load go up, right? And 2018, we actually saw about a 2% increase in carbon emissions from the US electricity grid, and that was driven by both increasing demand and the fact that natural gas plants had more generation than was offset by shutting down coal. So those two factors combined to have an increase in greenhouse gas emissions from the electric grid, where we'd actually been following the 3 years previously. So we had decreasing grid from electricity in 2015, 2016, and 2017. So I think that you will see certainly the potential for more transmission. The way that we can even out distributed generation to a large extent is by having more interconnection. And so I think that you'll see a continued push for more high voltage transmission lines. You will see increasing demand, while energy efficiency will certainly help. If we are all going to electric vehicles and to electric hot water heaters and electric heating and cooling, that's going to be a significant increase in the amount of generation that we need to have on the grid. And so I think that you will see continued renewables. I think that that's going to, though, vary significantly state by state. So how much of that comes onto the grid is going to depend. Storage is certainly becoming more and more of a player, especially to replace peaking capacity. So again, California actually is definitely showing the way here, but you've had a number of peaking plants that have actually been shut down, that have been replaced by large-scale battery storage. So you'll have storage both for peaking and to level out the intermittency of both wind and solar resources. But it's going to be a grid in transition. I think that the one thing that we can say about the electricity grid for the next 10 to 20 years is that it is not going to be static. It is not going to look like what it has for the last 100. And we're going to have to become comfortable with change and how the innovation that is occurring is going to be changing the operation of the grid itself.
Little solar house, so it charges by solar when available.
So I do have a Tesla Model 3. I will admit to it. It is parked outside. My other car is a 1985 diesel station wagon with 374,000 miles on it. So I can proudly say that I have both a diesel and an electric car. It is definitely a different experience, I will say.
I'm Laura Shemek. Is it possible that the increasing use of solar power by individuals will have an effect on the infrastructure?
Yes, and I think that you're seeing that play out one of two ways. So in places where you have very high penetration of solar, Hawaii, for example, is one. You have gotten to the point where almost the default for new installations is self-use. So you actually have gotten to the point where you don't expect to put it back out onto the grid. You expect to have batteries, and you actually intend to use most of that on your own property. So that is one way that states that have very high penetration are looking at dealing with it. California has taken a different approach. So every new single-family home built in California starting next year must have a solar panel equivalent to the expected use of that house when it is constructed. Now, will the majority of that energy be used actually by that particular resident? Probably not, right? That's a whole lot to try if you have an entire subdivision that all has essentially solar panels on their roof. So they're taking a different tact of actually having the utilities look at how the transmission and distribution infrastructure can handle that, and making it so that where you used to have peak pricing be essentially the middle of the day, 1 to 5 p.m., right? That was when we had all of our peaks because everybody was at work, but their air conditioners were also going. California peak now is not the middle of the day because of how much generation they have from solar. And so they're instituting mandatory time of use pricing for the entire state. And that peak will essentially be the evening because they want people to use all of the excess solar during the day and then actually be very efficient between when the sun goes down and when the wind starts blowing. So I think it goes to the fact that you will have a very different grid. Instead of a grid that is load following the way it is right now, I think you're going to see changes in customer behavior through things like time of use pricing, through things like Hawaii's self-generation program for solar, where consumers are actually thinking much, much more about when they're using electricity and where that electricity is coming from. Is it going to be a transition? Yes, right? This is one reason why the California utilities actually got a year longer to put in their time of use rates, because they recognized how much customer education was going to have to go into it. So we'll see.
gas distribution network, what other stranded gas assets are, I guess, are candidates in Pennsylvania?
Well, I mean, pipelines, just because it can't be recovered from ratepayers doesn't mean it can't be a stranded asset, right? It's just going to be paid for by the investors instead. So pipelines, production wells, that both of those can definitely be stranded assets. It's just who historically would actually be picking up the cost of the stranding.
And so that could include gas storage facilities,
Oh, yeah.
LNG facilities.
Yes, it could.
We have time for one more question if anyone has one. Well, if not, let's give Heather Payne